The B-2 Spirit bomber isn't just an aircraft. It's a legend, a ghost in the sky designed to strike anywhere on Earth without being seen. But even a ghost needs constant care. This isn't about flying fast or hitting hard. It's about staying invisible, and that invisibility is fragile. A $2 billion asset like the B-2 doesn't just sit in a hangar waiting for its next mission. It requires an army of dedicated individuals, a secret maintenance force working tirelessly behind the scenes to keep it mission-ready. Without their meticulous work, this ultimate stealth bomber would quickly become nothing more than an expensive paperweight. Our journey begins by pulling back the curtain on this hidden world, focusing on the intricate steps involved in preparing the B-2 Spirit for deployment. It's a story of precision, patience, and an unwavering commitment to perfection. Every chip, every scratch, every connection matters. We're going to explore the secret maintenance army and the critical, almost obsessive steps they take to ensure the B-2 remains the most powerful stealth bomber in the world. The B-2's mission success hinges entirely on its ability to remain undetected. This isn't just about the plane itself, but also about the weapons it carries. Even the most advanced bomber is useless without its payload, and preparing that payload is a science in itself. In a temperature-controlled facility kept at a constant 68 degrees Fahrenheit, members of the 509th Munitions Squadron begin their work. This precise temperature isn't for comfort, it's crucial for protecting the sensitive guidance systems of the Joint Direct Attack Munitions, or JDAMs. These aren't just ordinary bombs. They are smart weapons, and their intelligence is delicate. The initial assembly of a JDAM involves attaching the MAU-169 guidance section to the bomb body. This section is the brain of the weapon, housing a GPS antenna, an inertial measurement unit, and an umbilical connector. This connector is vital. It's the direct line of communication between the B-2 and the JDAM, allowing the aircraft to program the bomb's target coordinates just moments before release. Precision is paramount here. Technicians use specialized torque wrenches to ensure every bolt is tightened to an exact specification. This isn't guesswork. Over-tightening could crack the housing, while under-tightening could lead to vibration failure during flight. Either scenario would render the bomb useless, or worse, make it a danger to the very forces it's meant to protect. Once the guidance section is secure, the tail kit is attached. This kit includes the fins and actuators, which are independently controlled. These small yet powerful components make minute adjustments to the bomb's flight path, ensuring it stays on target. Before any JDAM leaves the facility, extensive pre-flight checks are performed. Actuator movement tests confirm that each fin can move freely and precisely. A single millimeter of error here could mean the difference between a direct hit and a 30-meter miss, an unacceptable outcome for a precision weapon. The final step in the preparation of each JDAM is its weighing. Every single bomb is weighed and its exact mass recorded. This isn't just for inventory. It's essential data for the B-2's ballistic calculations. The aircraft's computer system uses this precise weight to predict the bomb's trajectory, ensuring unparalleled accuracy. Safety is, of course, a constant priority. The JDAMs are completely safe and inert during all these stages. They are not armed, and their fuses remain unpowered. The thermal battery, which provides power to the guidance system, only activates upon ejection from the aircraft. This design philosophy ensures that these powerful weapons are harmless until the precise moment they are deployed. It's a system built on redundancy and caution, reflecting the immense destructive power these munitions hold. Before we continue, subscribe to the channel and tell us in the comments where you are watching from. The 509th Munitions Squadron's work is a delicate dance between raw power and meticulous engineering. Each JDAM, destined to become a pinpoint strike from the sky, starts its life in their controlled environment, a place where precision is not just a goal, but a strict requirement. The 68-degree Fahrenheit air is still almost reverent as technicians move with practiced efficiency, their movements honed by countless repetitions. This temperature isn't just about comfort, it's a shield against the subtle enemies of precision. Humidity and temperature fluctuations that could compromise the sensitive electronic components within the guidance kits. These kits, the MAU-169s, are the brains of the operation, containing the GPS antenna that will lock onto targets from thousands of feet up, and the inertial measurement unit that will track every subtle movement of the bomb in flight. The umbilical connector, a small but critical piece, is carefully inspected. This isn't just a plug, it's the lifeline, the communication pathway that will allow the B-2's advanced systems to feed crucial targeting data to the JDAM just seconds before its release. Any flaw here, any bent pin or loose connection, could sever that link and turn a smart bomb into a dumb one, missing its target by miles. The technicians understand this implicitly, which is why their focus never wavers. They use specialized torque wrenches, not just any wrench, but tools calibrated to apply exact pressure. The click of a torque wrench reaching its limit is a small sound, but it signifies a critical step completed correctly. Too much pressure, and the delicate housing of the guidance section could crack, compromising its integrity. Too little, and the constant vibrations of high-altitude flight could loosen components, leading to a catastrophic failure of the guidance system. It's a fine line, and these experts walk it with absolute certainty. After the MAU-169 is perfectly secured, the focus shifts to the tail kit. This isn't merely an aesthetic addition. It's an active flight control surface. The fins and their tiny, independent actuators are what give the JDAM its agile, precise maneuverability. Each fin must be able to articulate freely and respond instantly to commands. To ensure this, a series of pre-flight checks are performed. The actuators are put through their paces, moving the fins through their full range of motion. Technicians watch closely, looking for any hesitation, any stiffness, any sign that a fin might not respond exactly as designed. A deviation of even a fraction of a degree in these movements could translate to a significant error downrange, potentially causing the bomb to miss its intended target by 30 meters or more. For weapons designed for surgical strikes, such a margin of error is unacceptable. The final, crucial step in this preparation phase is the weighing of each JDAM. It might seem like a simple task, but its importance is immense. Every bomb is placed on a high-precision scale, its exact weight recorded down to the last gram. This data isn't just for inventory purposes. It's fed directly into the B-2's mission computer. The aircraft's ballistic calculations rely on this precise mass to accurately predict the bomb's trajectory, factoring in air density, speed, and release altitude. Without this exact weight, the B-2's unparalleled accuracy would be compromised. Throughout this entire process, safety remains paramount. These powerful munitions are designed with multiple layers of redundancy and fail-safes. On the ground, the JDAMs are completely inert. Their fuses are not powered, and their guidance systems are inactive. The thermal battery, which energizes the guidance electronics, only activates when the bomb is physically ejected from the aircraft. This ingenious design means that even if a JDAM were accidentally dropped or mishandled on the ground, it would remain harmless. It's a testament to the engineering philosophy that prioritizes safety above all else, ensuring that these weapons, capable of immense destruction, are only dangerous when their mission truly begins. While the munitions squadron meticulously prepares the weapons, another equally vital team focuses on the B-2 Spirit itself, the low observability technicians. Their mission is perhaps even more abstract than assembling bombs, because they fight a constant battle against the physics enemy. For the B-2, electromagnetic perfection is far more critical than mechanical perfection. A perfectly flying aircraft that shows up like a beacon on enemy radar is useless. This team's work ensures the B-2 remains invisible, a ghost in the sky. The B-2's unique advantage lies in its radar-absorbent material, or RAM. This coating is incredibly fragile, a delicate skin that can be damaged by almost anything. Birds hitting the aircraft, hailstones, even heavy rain at high speeds can chip or wear away this vital layer. Every single inch of the B-2's surface must be a perfect, seamless curve, designed to absorb radar waves rather than reflect them. Any imperfection, no matter how small, can create a radar signature, turning the B-2 from an invisible threat into a detectable target. The inspection process conducted by these technicians is exhaustive. They go over the entire aircraft, often using specialized lights and tools, looking for the tiniest flaws. Chips, bubbles forming under the surface, scratches, or even areas that feel slightly rough to the touch are immediately flagged. Imagine trying to find a single grain of sand on a vast beach. That's the level of detail required for these inspections. They understand that radar waves, moving at the speed of light, will find any anomaly. Certain areas of the B-2 are particularly critical. The leading edges of the wings, where the aircraft first encounters air and potential impacts, are constantly scrutinized. Similarly, the engine air intakes are primary radar reflectors if not properly maintained. These openings, despite their complex internal baffling designed to hide the engine blades, can still present a challenge. Any degradation of the RAM in these zones is a major concern, as it directly compromises the aircraft's stealth capabilities. Another crucial aspect of their work involves the panel joints. The B-2 is not a single, solid piece of metal. It's made up of many panels. Where these panels meet, there's a seam. Even a microscopic gap can act like a corner reflector for radar waves, bouncing them back to the source. To prevent this, the technicians use a special conductive tape. This tape isn't just sticky. It's designed to create a perfectly smooth, electrically continuous surface across the joint. The precision required here is astonishing. A gap the width of a credit card can increase the B-2's radar signature significantly. This means the tape must be applied with absolute accuracy, ensuring no air bubbles, no wrinkles, and a perfectly flush finish with the surrounding RAM. The work is slow, methodical, and incredibly repetitive. Yet each technician understands the immense stakes involved. They are the guardians of the B-2's invisibility, the unsung heroes who ensure that when the bomber flies, it truly remains a ghost in the night sky. Their expertise isn't just about applying materials. It's about understanding the complex physics of radar and how to defeat it, one microscopic imperfection at a time. It's a testament to the fact that even the most advanced technology requires human ingenuity and relentless dedication to maintain its edge. When a flaw is found, the low observability technicians don't just patch it, they meticulously sculpt a repair that restores the B-2's perfect radar-absorbing surface. The repair process starts with careful preparation of the damaged area. Using specialized fine grit tools, they sand away the compromised RAM, ensuring a smooth transition from the damaged spot to the intact material around it. This isn't just about removing the bad. It's about creating a perfect foundation for the new material. The sanding needs to be precise, removing only what's necessary without creating new imperfections or thinning the surrounding stealth coating too much. It's a delicate balance, requiring a steady hand and an expert eye, because any unevenness will show up on a radar screen. Next comes the mixing and application of the new RAM compound. This material is not a simple paint. It's a complex blend of polymers and radar-absorbing particles engineered to dissipate incoming radar waves as heat. The mixing process itself is time-sensitive and requires absolute precision. The compound often has a limited working life once mixed, meaning the technicians must work quickly and efficiently. Temperature and humidity in the hangar are carefully controlled to ensure optimal curing conditions. If the compound isn't mixed correctly, or if it cures too fast or too slow, its radar-absorbing properties will be compromised. An improperly repaired section won't just fail to absorb radar, it could actively reflect it, turning a stealthy aircraft into a flashing target. This is why the technicians treat every repair with the gravity of a life-or-death situation. Applying the RAM compound is an art form. It's often layered on, building up the thickness gradually, much like a sculptor adding clay. Each layer must be perfectly smooth and free of air bubbles or inconsistencies. They use specialized applicators and tools to spread the material evenly, ensuring uniform thickness and density. The goal is not just to cover the damaged spot, but to seamlessly integrate the new material with the old, creating an uninterrupted surface that radar waves will simply ignore. They understand that every micron of variation can have an impact. Once the compound has cured to the right consistency, the final sanding and finishing begin. This is perhaps the most critical stage. The technicians use precision gauges and their highly trained sense of touch to achieve an astonishing level of smoothness. The standard for surface variation is incredibly stringent, less than a few sheets of paper over a foot of surface area. To put that into perspective, imagine trying to find a bump smaller than a human hair on a car hood and then making it disappear. This level of perfection is essential because even the slightest ridge or depression can scatter radar waves, creating a detectable signature. They often work under special lighting that highlights any imperfections, allowing them to meticulously sand and buff until the surface is absolutely flawless. This entire repair process is incredibly time-consuming. It's not a quick fix. It's a detailed, multi-stage operation that can take hours or even days for a single damaged spot. The B-2 isn't just being fixed, it's being carefully sculpted back to its original, radar-invisible form. The technicians aren't merely mechanics. They are artisans of invisibility, using their skills to maintain the B-2's most valuable asset. Their work is a constant reminder that the B-2's stealth isn't a passive quality. It's an active, ongoing battle against the laws of physics, fought and won one meticulous repair at a time. The success of the B-2 and the safety of its pilots hinges on their unwavering dedication to this demanding craft. Every hour spent perfecting a surface ensures that the B-2 can fulfill its mission, undisturbed and undetected. While the low observability technicians are meticulously sculpting the B-2's stealth coating, other personnel are hard at work inspecting the aircraft's complex mechanical systems. This maintenance happens in parallel, a symphony of specialized teams ensuring every component is in perfect working order. They understand that stealth is crucial, but a non-functional aircraft, no matter how invisible, is useless. Their focus is on the hundreds of moving parts and intricate networks that allow the B-2 to fly, deploy weapons, and keep its pilots safe. One of the most critical systems they scrutinize is the hydraulic system. The B-2 Spirit relies on hydraulics for nearly everything, controlling its massive elevons, operating the landing gear, and even actuating bomb bay doors. What makes the B-2's hydraulic system particularly complex is its redundancy. There are 4 completely separate hydraulic systems, each operating at extreme pressures, designed to take over if another fails. Technicians meticulously check every line, valve, and pump for leaks, wear, or any sign of diminished performance. A tiny drip could indicate a larger problem, potentially leading to a catastrophic failure during a mission. They use specialized tools to test pressure levels and fluid integrity, ensuring that all 4 systems are ready to perform under the immense stresses of high-altitude flight and high-speed maneuvers. The flight control actuators are another area of intense focus. Given the B-2's unique tailless design, it doesn't have a conventional rudder or elevator. Instead, it relies entirely on its elevons and other control surfaces to maneuver. These surfaces are moved by powerful hydraulic actuators. Technicians carefully test each actuator, looking for any sluggishness, unusual noises, or deviations from their precise movement specifications. A slight delay in an actuator's response could mean the difference between a smooth correction and an uncontrolled roll, especially in turbulent air or during a critical bombing run. They ensure that every control surface moves with the exact precision required for such an aerodynamically challenging aircraft. Beyond hydraulics and flight controls, a myriad of other critical components undergo rigorous inspection. The landing gear, for example, must be able to withstand the immense weight of the aircraft upon landing, especially when fully loaded. Technicians inspect the struts, tires, and braking systems for any cracks, wear, or fluid leaks. The tires, specifically, are checked for proper inflation and tread integrity, as they are the only point of contact with the ground. The environmental systems, which maintain a habitable temperature and pressure inside the cockpit for the pilots, are also thoroughly tested. Any malfunction here could compromise pilot performance or even safety at extreme altitudes. The electrical buses, which distribute power throughout the aircraft, are checked for continuity and proper voltage, ensuring that all avionics and weapon systems receive stable power. The inspection process is methodical and exhaustive, leaving no stone unturned. Every component, no matter how small, is vital to the B-2's operational capability. There's a strict protocol for any detected issue. Any system failure, no matter how minor, immediately halts the next step in the preparation process, typically weapon loading. The aircraft must be absolutely perfect, mechanically sound from nose to tail, before it can be deemed mission-ready. This meticulous attention to detail by the mechanical inspection teams ensures that when the B-2 finally takes to the sky, it is not only invisible to radar, but also a flawlessly operating machine, ready to execute its mission without a hitch. Their work complements the stealth technicians, creating a bomber that is both unseen and unstoppable. With the B-2 declared mechanically flawless and its stealth coating perfectly restored, the focus shifts to arming the unseen giant. This is where the armament loaders step in, a team whose precision is as critical as any other. Their task is to carefully position the JDAMs, which have been meticulously assembled and checked by the 509th Munitions Squadron beneath the aircraft. This isn't a simple process of attaching bombs to external pylons, as the B-2's unique design dictates an internal carriage system. There are no external weapons on a B-2, a crucial element for maintaining its stealth profile. The JDAMs are moved into place using specialized hydraulic lifts, carefully guided by the loaders to prevent any damage to the delicate stealth surfaces of the bomber or the weapons themselves. The bomb bay doors of the B-2 are massive, a testament to the sheer volume of ordnance the aircraft can carry. These doors are not just large, they are engineered with an astonishing degree of precision. Their alignment is absolutely critical, designed to create a perfectly smooth, continuous surface when closed. Any gap, any misalignment, no matter how small, could create a radar reflection, compromising the B-2's invisibility. The armament loaders work with these doors, which open wide to reveal the heart of the B-2's offensive capability. Inside the bomb bay, the JDAMs are loaded onto a rotary launcher. This system is essentially an enlarged version of a revolver cylinder, capable of holding a significant number of weapons. In the case of the B-2, each rotary launcher can hold 8 200-pound weapons, allowing for a substantial payload. The design of this launcher is a marvel of engineering, balancing the need for rapid deployment with the requirement for absolute reliability. The loaders carefully attach each JDAM to its designated position on the rotary launcher, ensuring a secure fit. The rotary launcher's ability to rotate 360 degrees in under 3 seconds highlights the immense forces involved in weapon deployment. This rapid rotation is essential for quickly cycling through weapons during a mission, allowing the B-2 to deliver multiple ordnance packages in rapid succession. The loaders understand that their work directly impacts the speed and efficiency of weapon release, which can be critical in dynamic combat situations. Every connection point, every lock, must be perfect to withstand these forces. Each JDAM is secured to the rotary launcher by suspension hooks. These hooks are engineered to be incredibly robust, designed to safely hold up to 14 pounds of force. This seemingly excessive capacity accounts for the significant G-forces the weapons might experience during the B-2's maneuvers. Even though the bombs are internal, they are still subject to the stresses of high-speed flight and evasive actions. The loaders meticulously engage these hooks, ensuring that each weapon is firmly in place and will not shift during flight. A loose weapon could not only damage the aircraft, but also become a hazard during deployment. Their attention to detail here is paramount, guaranteeing that every JDAM remains safely stowed until the precise moment it is needed. This entire process is a choreographed dance of precision and strength, preparing the B-2 to deliver its powerful payload with unmatched stealth and accuracy. With the JDAMs securely nestled within the rotary launcher, the armament loaders move on to the next critical step, establishing the interface between each weapon and the B-2's complex systems. This isn't just about physical attachment. It's about making sure the aircraft can communicate with every single bomb it carries. A precise mechanical alignment is absolutely necessary for the power and data transfer to occur. Each JDAM has a set of connectors that must perfectly mate with corresponding ports on the rotary launcher and, by extension, the aircraft's armament management system. Any misalignment, even a fraction of a millimeter, could sever the digital link, rendering the bomb ineffective or causing it to fail to release. The loaders engage the lug-locking mechanisms. These aren't just simple clamps. They are designed to secure the weapons firmly in place while simultaneously enabling a robust communication pathway. Once the lugs are locked, a series of electrical and data connections are established. This is where the magic of modern warfare truly happens. Data transfer is crucial, as this link allows the B-2 to feed the bomb its targeting information. Without this connection, the JDAM would be nothing more than a very heavy, unguided piece of metal. The aircraft's computers upload the precise coordinates, trajectory, and other flight parameters directly into the bomb's guidance system. One of the most impressive capabilities of this system is the ability to make in-flight target changes. Unlike older bombing methods where targets were pre-programmed and unchangeable once airborne, the B-2 can receive updated intelligence during a mission. If a new, more critical target emerges, or if the original target's coordinates shift, the pilots can input these changes. The armament management system then relays these new coordinates to the JDAMs, often just seconds before their release. This real-time adaptation gives the B-2 unparalleled flexibility and responsiveness in a dynamic combat environment. It means the aircraft isn't committed to a target until the very last moment, maximizing its operational effectiveness. It's important to understand the safety philosophy behind these weapons. On the ground, the JDAMs are inert. They are essentially dumb weapons. Their fuses are unpowered, and their guidance systems are inactive. This design choice is a fundamental aspect of safety protocols. A bomb sitting in the bomb bay, or even being moved around the hangar, poses minimal risk. It's not armed, and it cannot accidentally detonate. The guidance systems only become active, drawing power, once the bomb is released from the aircraft. Even then, the thermal battery that powers the guidance system only activates upon ejection, and the fusing mechanisms are typically armed only after the bomb has cleared the aircraft and is on its way to the target. This design philosophy of keeping the weapon dumb until the last possible second is a critical safety measure, protecting both the ground crews and the aircraft itself. It minimizes the chances of accidental activation or detonation during loading, flight, or even in the event of an aircraft malfunction. The armament loaders are keenly aware of this. They handle these powerful munitions with immense respect, but also with the confidence that comes from knowing the weapons are inherently safe until their intended deployment. Their meticulous work ensures that when the time comes to deliver the payload, the JDAM will not only be perfectly aligned and connected, but also ready to receive its final instructions and execute its mission with deadly precision. This intricate dance of mechanical precision and digital communication is a testament to the engineering marvel that is the B-2 Spirit, ensuring that every weapon released is a smart weapon. The meticulous preparation of the B-2 Spirit and its munitions culminated in a single, overarching goal: mission success, which inherently meant ensuring the safety of the pilots. The ground crews, a diverse team of specialists ranging from munitions experts to low observability technicians and mechanical system inspectors, all played a critical role in verifying the aircraft's readiness. Their work, though often unseen by the public, directly translated into the confidence and security felt by the individuals who would ultimately steer this sophisticated machine into harm's way. Every bolt tightened, every wire checked, every stealth coating repaired contributed to a chain of trust that began on the ground and extended into the cockpit. For the pilots, knowing that every component had been scrutinized, every system tested, and every weapon perfectly integrated was paramount. They relied on the ground crew's expertise, understanding that any oversight could have catastrophic consequences. Before a mission, the pilots would receive comprehensive briefings on the aircraft's status, including any maintenance performed, ensuring they were fully aware of its operational capabilities. This wasn't just a formality. It was a deep dive into the health of their multi-billion-dollar airframe, a testament to the symbiotic relationship between those who maintain and those who fly. They would review logs, discuss specifics with the crew chiefs, and conduct their own pre-flight checks. But the foundation of their confidence was always the diligent work done by the maintenance teams. The ground crew's responsibilities extended beyond just fixing things. They were the guardians of the B-2's operational integrity. They understood that the extreme pressures of a combat mission left no room for error. A pilot, for instance, wouldn't have the luxury of troubleshooting a hydraulic leak or a faulty guidance system while evading enemy radar. Therefore, the ground crews meticulously ensured that such issues were identified and resolved long before the aircraft ever left the hangar. This commitment to perfection was not just about protecting an expensive asset. It was about safeguarding human lives. The pilots were entrusting their lives to the aircraft, and by extension, to the skill and dedication of the maintenance personnel. The coordination between various teams was seamless. The 509th Munitions Squadron made sure the JDAMs were flawless. The low observability technicians guaranteed the B-2 remained invisible. The armament loaders ensured the weapons were integrated perfectly, and the mechanical system inspectors confirmed every moving part functioned as intended. All these efforts converged to present the pilots with an aircraft that was not just capable, but exceptionally reliable. Their final checks on the flight line, often under the watchful eyes of the pilots, were the last assurance that the B-2 was truly mission-ready. They performed final visual inspections, confirmed fuel loads, and ensured all access panels were secured, leaving no stone unturned. This intricate dance of preparation, involving hundreds of hours of labor and countless checks, was a silent promise made by the ground crews to the pilots. It was a promise that they had done everything humanly possible to ensure the B-2 would perform flawlessly, allowing the pilots to focus solely on their mission. The pilots, in turn, carried the weight of that trust into the skies, knowing they were backed by the unwavering dedication of the secret maintenance army. Their safety was engineered into every aspect of the B-2's design, and maintained through the tireless efforts of these unsung heroes. When the B-2 Spirit finally taxied down the runway, its powerful engines roaring to life, it wasn't just a technological marvel taking flight. It was the culmination of countless hours of meticulous work, a testament to the profound commitment to excellence that defined every individual involved in its readiness. The roar was not just of the engines, but of a collective assurance that everything was exactly as it should be, ready for whatever lay ahead.